Alright, hello everybody. This video is going over the 1.1 multiple choice and FRQs in the Unit 1 booklet for AP Chemistry. Number 1 says a solution is prepared by adding 16 grams of methanol to 90 grams of water. The mole fraction of methanol in the solution is closest to which of the following? So first we need to identify what it's asking for in this question. It's asking for the mole fraction of methanol in the solution. Then we need to identify what it's giving us in order to solve the problem. That information will be the 16 grams of methanol and the 90 grams of water. Now at this point, you should identify what a mole fraction is. And basically what it is just a ratio of the solute and the solution. So the equation for a mole fraction would be moles of solute over moles of solution, or a part over the whole, which is what we talked about in class. Now just in case, I'm going to go over the terms solute and solution just to make sure we're clear on these terms and the concept behind solutions. So when you have a solution, it's made up of a solute and a solvent. Now the solute is a substance that is being dissolved, while the solvent is dissolving that substance. So in this case, the solute would be methanol and the solvent would be H2O. So now that we know that our mole ratio is going to be the moles of methanol over the moles of the entire solution. So now that we know we need to solve for moles of methanol and moles of water to get the moles of the solution, we can go ahead and start converting the grams that we were given of each into moles. So remember, when we're converting from grams to moles, we want to be dividing by the molar mass. So when we add up the molar mass for methanol, it's going to come out to 32.042 grams, and that's equal to 1 mole of methanol. When we do that math, we end up with 0.499 moles of methanol. Now we're going to do the same concept with water, where 1 mole is equal to the molar mass. And that's going to give us 4.99 moles of water. So now that we have our moles of solute and moles of solvent, we can identify our moles of solute over our moles of solution, which are both added together. So to solve for the mole fraction of methanol, we're going to take our part, which is methanol, put it on the top, 0.499. Remember, this has to be in moles since it's a mole fraction, over the moles of the entire solution, which would be both methanol and water. So we're going to go ahead and do 0.499 plus 4.99. And when we do that, we end up getting 0.1. And that is the ratio of methanol to the entire solution. So our answer here would be A. All right, number 2 says a solution of methanol in water is prepared by mixing together 128 grams of methanol and 108 grams of water. The mole fraction of methanol in the solution is closest to what? So this question is extremely similar to number 1. So we are solving for the mole fraction of methanol in the solution, and we are given grams of methanol and grams of water. So just like last time, we will be solving for the mole fraction, which is moles of solute over moles of solution. And then we're going to take our 2 given masses and convert them to moles. So from our last example, we know that the molar mass of methanol is 32.042. and that is equal to 1 mole of methanol. When we do that math, we end up getting 4 moles of methanol. And then we can go ahead and do the same thing for water. So we know that in 1 mole of H2O, we have 18.02 grams of H2O. That's going to end up giving us 6 moles of H2O. Now that we have our moles, we can go ahead and solve for the mole fraction. Since we know we're solving for the mole fraction of methanol, we're going to put the moles of methanol in the numerator because that is the solute. And then in the denominator will be the moles of the entire solution, which is the solute and the solvent. So we're going to add the moles of methanol and the moles of water to get the moles of the solution. In this case, it would be 4 plus 6, or 10. That would give you a final mole ratio or mole fraction of 0.4. All right, so in number 3, it says how many carbon atoms are contained in 2.8 grams of C2H4. So we know how to convert from grams to moles to then particles, right? Well, when you're in particles, or in this case molecules, remember for every molecule of C2H4, you're going to have 2 carbon atoms. So let's start out by converting our grams of C2H4 all the way to particles. So our first step is going to be getting our grams into moles, and we do that by dividing the molar mass. So we know that in 1 mole of C2H4, we can add up the masses of all of those atoms, and we get the molar mass of 26.036 grams. So now we are currently in moles of C2H4 since those grams are canceling out. Now to get to moles of carbon, what we're going to do is we're going to take our 1 mole of C2H4 and we're going to cancel out that. So we know we want moles of C2H4 on the denominator. And we know that in 1 mole of C2H4, we have 2 moles of carbon. And that just is associating to this subscript right here. So now that we're in moles of carbon, we can go ahead and get to atoms of carbon by using Avogadro's number. And we know Avogadro's number is equal to 1 mole. So in 1 mole of carbon, we have 6.02 times 10 to the 23rd atoms of carbon. So now, if we look at all of our units, we can ensure that they all cancel out. So we have grams gone, moles of C2H4 gone, moles of carbon gone, and we're left with atoms of carbon, which is what we are solving for. And then we can go ahead and do the math. So in your calculator, if you do 2.8 divided by 26.036, press equals, then multiply it by 2, press equals, and then multiply it by 6.02, you will get 1.2. Then you do have to carry over this exponent, so times 10 to the 23rd. Since this is in scientific notation, which is a number between 1 and 10, this would be your final answer. If you look at your answer choices, that would be A for your answer. Number 4 says in 1 mole of potassium zirconium sulfate trihydrate, there are 5 answer choices. So what we have to do is we have to go through the 5 answer choices and identify which one is true. So A is referring to the hydrogen atoms. So let's go to our original compound and identify how many hydrogen atoms we have. Now in the equation, we have a 3 in front of water, which means this 3 is multiplying the amount of hydrogen. So we have 6 hydrogen atoms in this compound. So when we are trying to get the amount of particles, that means you'd have to multiply 6 by 6.02 times 10 to the 23rd. So this A would be incorrect. Let's move on to B. So B says potassium atoms. So let's identify how many potassium atoms we have in this compound. In the compound, we have 4 potassium atoms, which means if we converted it to particles, we'd have to multiply 4 by Avogadro's number. So B would be the correct answer for this question. Now we're just going to continue on, just in case answer choice B was actually E on the test and you had to do some more process of elimination. Choice C is referring to sulfur atoms, and if we go into our original compound, you'll see that this 4 is multiplying the sulfur atoms. So we technically have 4 sulfur atoms, which means C would be incorrect because Avogadro's number would have to be multiplied by 4. Then if we go to D, it's referring to oxygen atoms. Now, option D says that there are 4 moles of oxygen atoms. However, we have 4 times 4, which is 16, plus 3 times 1, which is 3. So we have a total of 19 oxygen atoms in this compound, so D would definitely not be correct. Then we go to E, 4 moles of zirconium atoms. And you can see in the original compound that there is only one zirconium atom, so E would also be incorrect. All right, number 5 says a student has a 1 gram sample of each of the following compounds. Which of the following lists the samples in order of increasing number of moles? So we are solving for the increasing number of moles of all of these samples, and we are given 1 gram of each sample. So what we can do is we can start with 1 gram of sodium chloride, 1 gram of potassium bromide, and 1 gram of potassium chloride. And we can convert all of those to moles by dividing the molar mass. So for sodium chloride, we end up getting 0.0171 moles of NaCl. For KBr, we end up getting 0.0084 moles of KBr. And for KCl, we end up getting 0.0134 moles of KCl. So now that we have the moles of our 3 samples or 3 compounds, we can go ahead and put them in increasing order. So our smallest one would be KBr at 0.0084 moles. Then the next largest one would be KCl at 0.0134 moles. And our largest one would be NaCl at 0.0171 moles. So the answer to this question would be D. KBr being the smallest and NaCl being the largest. All right, number 6 says a student obtains a sample of a pure solid compound. In addition to Avogadro's number, which of the following must the student know in order to determine how many molecules are in the sample? Now we know we are solving for how many molecules are in the sample, and we know that we are given a sample of a pure compound. So what it's asking is, what do we need from that original sample in order to solve to molecules? Now what we're going to do for this, if you don't understand the answer right away, is we're going to solve backwards dimensional analysis. So we know to end up with molecules, we're going to have a final conversion factor of 6.02 times 10 to the 23rd molecules equal to 1 mole. Now, we know from here going backwards that we're going to have 1 mole of that substance over molar mass. So that's going to be the molar mass of our substance in grams. And we know when we're getting an original sample, we're going to obtain a mass of that sample in order to convert it into molecules. So our answer to this question would be that we need the original mass of the sample and we need the molar mass of that compound. So our answer here would be choice C. Number 7 says, which of the following numerical expressions gives the number of particles in 2 grams of neon? So we are basically saying that you need to solve for the number of particles, but you are given grams of neon. So we need to convert from grams of neon to particles. So we're going to do that by taking our 2 grams of neon. First, we need to get it to moles by using the molar mass. We know the molar mass of neon is 20.18 grams. And now that we're in moles of neon, we can go ahead and use 1 mole is equal to Avogadro's number. That will get us 2 particles. So this will give us our answer, but it's not asking for the answer, it's asking for the setup. So if we look at our answer choices here, if we condensed our math that we just did, you would end up getting C as your answer. Because we have 2 grams divided by the molar mass and then multiplied by Avogadro's number. So C would be your answer for number 7. Number 8 says, according to the information in the table shown, a 1 gram sample of which of the following contains the greatest mass of oxygen? Now, you could definitely do math to solve this problem, but you can also use logical reasoning to solve this problem as well. So since we have one oxygen atom in every single compound, we know that if we take a gram sample and divide by the molar mass, the smaller the molar mass, the more moles it's going to produce. So we can just look at the smaller molar mass, and that's going to give us MgO, and that would end up being our answer. However, you can also solve this if you are unsure on how to come up with that reasoning on your own. If we take a 1 gram sample of all of these compounds and then divide by their molar mass to get to moles, and then convert from moles of compound to moles of oxygen, then you can do the math on how many moles each one of these substances would produce of oxygen. That would end up giving us 0.016 moles of oxygen for Na2O, 0.0248 moles of oxygen for MgO, 0.0106 moles of oxygen for K2O, and 0.0178 moles of oxygen for CaO. So as you can see, what we find here is that MgO produces the most amount of oxygen, which is exactly what we said at the very beginning of this question. So we know that the smaller the molar mass, the more moles it will create if it's all the same amount of sample. And then last up we have our FRQ question for 1.1. There's only one, but there are 3 parts. It says, answer the following questions related to the analysis of CaBr2. A states a student has a 10 gram sample of CaBr2. Show the setup of the calculation to determine the number of moles of CaBr2 in the sample. Include units in the setup. So we don't actually have to solve, but we just have to write out our dimensional analysis to go from grams of CaBr2 to moles of CaBr2. So we're going to start with our 10 grams of CaBr2. And we know in order to get to moles, you simply take 1 mole of your compound and divide by the molar mass. And if we take the molar mass of CaBr2 from the periodic table, adding up all of our atoms, we get 199.88 grams of CaBr2. Now you don't actually have to solve this question. All you had to do is show the setup in order to get the answer. Now B is saying what number, in addition to the answer to part A, is needed to determine the number of atoms of Ca in the sample. So since we're in moles of our compound, the number that we would need to get to number of atoms would be Avogadro's number. So the only answer to B would be Avogadro's number, or 6.02 times 10 to the 23rd atoms. C states a different student is given a 10 gram sample labeled CaBr2 that may contain an inert impurity. Identify a quantity from the results of laboratory analysis that the student could use to determine whether the sample was pure. So to answer this question, you could have given one of 4 answers. So there were many different choices you could have chosen from. So if you know that the overall sample is 10 grams, in order to identify whether it's a pure sample or not, you would need either the mass of calcium in the sample, the mass of bromine in the sample, and that would give you a starting point to solve all the way to grams of the entire compound. Or you could even be given the number of moles of calcium or the number of moles of bromine in the sample, and then that's actually one less step to solve for grams of the entire compound. And again, you only need to write one of those 4 answer choices. It was not asking for all of the answer choices, just for one option. Alright everybody, I hope this video helped you through the 1.1 section of multiple choice and FRQ questions. If you have any questions beyond these, please let me know and I'm happy to help at any time. I will see you tomorrow.